Hello everyone, I'm Abhishek from Minerva and today we are going to start at one of the most interesting topic for you people, that is light. So in the chapter of light, the first question that will comes on your mind, that is what is light, right? So light is a one form of energy till we know that, right? It's a one form of energy. So what type of energy it is? What's the property it has? Now maximum of the scientists have do many researches on that. The branch of physics will do the research on the properties of light and various kind of experiments about that. The branch is known as optics, right? So with the help of light energy, what we can do, we can see all of the things in our surroundings, right? The colorful things or the colorful wings of a butterfly, the rainbows, even all of the colors we are able to recognize when the light just fall on it, right? So in this chapter what we are going to learn, that is what's the properties of light and the reflection of light, the refraction of light, and many more things. Okay, so we are starting from the properties of light. Let me define what is light. So at first I will write down the property that it is a non-mechanical wave. What it is? It is a non-mechanical wave. Why I have written that non-mechanical wave? Because it does not need any mechanical things to travel. It does not need the air or any kind of solid or any kind of liquid medium to travel. And I have written that it is a one kind of wave. Now some of the scientists have defined that the light is a one kind of wave, but it is having the particle nature as also. Particle nature means, that means light is a source of energy, right? It is also known as an electromagnetic wave. Why it is said it is an electromagnetic wave? If we define that, it is known as an electromagnetic wave because in that case, if we draw that, suppose the electrical waves are traveling in that direction, right? Suppose the electrical waves are traveling in that direction and the magnetic waves are traveling in that direction. Suppose the magnetic waves are traveling in that direction. Light is known as an electromagnetic wave. Why it is said that it is a one kind of electromagnetic wave? Because if we just draw the diagram, then it can be seen that the magnetic waves are like that. If the magnetic waves are like that, the electrical waves will be like that. The electrical waves will be like that. So in that case, what can be seen, that it's a one kind of transverse wave because it is moving perpendicular with respect to its propagation, right? Because the electrical waves and the magnetic waves, suppose this is the magnetic waves and these are the electrical waves, right? So these two waves are perpendicular with each other. In this diagram, I know it is not very much of clear. It should be a colorful diagram, but in that case, we are able to assume that the electrical waves and the magnetic waves, they are inclined with each other at an angle of 90 degree. So in that case, the light wave is propagating with respect to the perpendicular with respect to the propagation of these two waves. So that's why we can say that it's a one kind of transverse wave. So it can be the second point, that it's a transverse electromagnetic wave, right? So electromagnetic wave, that means it can be deviated with the help of an electric field as well as in the case of a magnetic field also, right? So these two properties we are able to draw up to that point. So after that, what can I say? That it is having a wavelength. The visible light is having a wavelength of, it is having a wavelength of 400 to 700 nanometer, right? Because if you know the spectrum, now it consists of different types of light waves. Suppose there are some microwaves, there are some infrared, the radio waves, even the X-rays, the UV rays, but the visible light spectrum is about the wavelength of 400 to 700 nanometer. We are just able to view the light within this small. We are just able to get the light energy within that wavelength. Now light itself is invisible, but with the help of that energy we are able to see all the surrounding things, right? Now if we draw the last property, that is what the speed of light. Light speed in air or light speed in vacuum is assumed to be, that is speed of light, we can say it is about 3 into 10 to the power 8 meter per second, or you can say it is having a speed of 3 into 10 to the power 10 centimeter per second. So some of the properties we have just lined up, that it's a non-mechanical wave, that's why it is don't need any kind of medium to travel, right? It's a one kind of transverse electromagnetic wave. It's a combination of electric and magnetic wave which are inclined each other at an angle of 90 degree, right? And it's a transverse wave because it is able to propagate with respect to it's a one kind of transverse wave because it is able to move with respect to 90 degree with the propagation of these two waves. Now we are able to draw the next property, that it is having a wavelength of 400 to 700 nanometer. And it is having a speed of 3 into 10 to the power 8 meter per second in SI and 3 into 10 to the power 10 centimeter per second in CGS, right? These are the four basic properties. That's the basic introduction of light, right? Now the next thing comes that why that the light waves have travel in a only straight line, or they can travel in a curved way also. That thing will strike on your mind. Let's go for its solution. Now light waves always travel in a straight line. That means if I draw that, light waves always travel in a straight line. But it is not like that you are using a source of light over here. Suppose you are using a source of light over here and only the light waves are traveling in that direction. The light waves travel in that direction. In all of the possible direction, it is able to just move, but they always move in a straight line. So that's why we'll know the motion of these light waves as a translation motion. Okay. Now we are just going to move that when the light waves, with the help of the light waves, we are able to recognize the color of the objects, because sometimes we see that this whiteboard is white, right? If it is what a blackboard, it is looking black. Now the leaves of the plants, they are green. Why it is like that? Because of the reflection of the light waves. Suppose the light waves are coming to one of the objects, and the three things can happen. After falling of the light waves, the light wave can be reflected. The light wave can be reflected. It can be absorbed, or it can be transmitted. Right? These three things can be happen. So when the light wave is being reflected, suppose I'm just talking about a surface. Suppose in this case the surface is black. In this case I have just drawn a surface and the surface is fully black. So what will happen when the light wave will come? The light wave is consist of 7 colors, right? Because whenever we use the light wave, it's actually a white light. The white light is a combination of 7 colors of light, which is known as Vibgyor, we think, right? So if the light wave is falling on that, if the light wave is falling on that black surface, then maximum all the light waves will be absorbed with the help of this surface. No one of the light waves will be transmitted from that, or it cannot be reflected as well. Okay. Now if that surface is in this case is black, so in that case maximum of the light waves will be absorbed by that surface. Now when a surface looks white, now this is a surface which looks white, right? Now I have just drawn a border over here, but the surface is actually a white. So when the surface looks white, now in this case the blackboard, this portion of the blackboard is white. Why it is white? Because all of the lights are coming to this blackboard getting reflected. No one of the light is being absorbed. Maximum of the light is being reflected. If you are watching that this portion is slight bluish, that means blue light is greater reflected, right? All of the lights are falling on that blackboard will be perfectly white when the maximum of the light will be reflected. No one of the light wave is absorbed. But if it is a bluish in nature, that means blue light is something absorbed by the surface and it is greatly reflected. Now, so when can I say if the surface is white? When you see the surface that it is white, that means maximum of the light waves have been reflected. So that's why you are able to say that that surface is white. When can I say that the surface, in this case I have drawn, this is a red surface. When can I say there is a red surface? Suppose it is fully red. Okay. Now a beam of light is coming to this surface. Okay. In this case, a beam of light is coming to this surface, and in this case, we are able to see that the surface is red. How we are able to see? Because only red light is reflected from this surface. Only red light is reflected from this surface. Now, when the light wave will come, in this case, I have just drawn it with the help of a red ink, but the light wave come to this surface, it's constitutes of 7 colors, but maximum of the colors have been absorbed, but only the red light is reflected. So that's why you are able to see that the surface is red only here. I hope it is clear. So in the first case, we have seen that the surface will be black if you just see that the light wave is coming to this surface and all of the light waves are being absorbed. No one is reflected, so it is black. Now when the surface will be white, when all of the light waves are coming to this and maximum of the light waves are being reflected. So nothing is absorbed. So in this case, this is a simple white portion of that board. Now when a surface becomes red, blue, green or anything, when the light waves are coming but only the red light is being reflected, then we can say that the surface is fully red. Now with the help of these properties, with the help of this phenomena, we are just able to understand the concept of reflection. What is reflection? Let's understand it. There is a new concept, that is of reflection. What is reflection? Suppose this is a plane, okay? One of the sides is coated with silver. That means light cannot pass through this medium. So if a light wave is coming to this medium and it is going back to the same medium, then we can say this phenomena is known as a reflection. Suppose a light wave is coming from one of the medium. It can be air, it can be liquid, any kind of medium. If the light wave is coming from that medium and it is getting, after incidenting at this point, it is going back to the same medium. So this phenomena is called the reflection of that light wave. But in this case, we have to follow the law of reflection, right? That we have already studied from class 8, right? So we'll revise that portion again over here. So in this case, this point is known as a point of reflection. This is known as point of reflection, right? To understand the laws of reflection, we have to know some of the things about the light wave. So in this case, this is the incident ray. This is the incident ray. This is the reflected ray, right? And at this point of reflection, if we draw a perpendicular over here, then what can we say according to the law of reflection? That the incident angle I is equals to the reflected angle R, right? That is, the incident angle I is equals to the reflected angle R. And the second law, this is the first one. The second thing, what can we say? That the incident ray, the reflected ray and the normal lying on the same plane, right? This is the normal we have just drawn over here, right? The incident ray, the normal and the reflected ray, all of are lying on the same plane. Now let's solve a problem. Now if it is given, this is a question number 1. If it is given that a light wave is coming like that and it is reflected. Okay. Now in that case the medium is water. In this case the medium is water. And in that question it is given if that angle is equals to 60 degree. That means it is the incident angle. Now in this case, if the incident angle is 60 degree, what will be the value of the reflected angle? In this case, this is a small 1 marks question actually. Now in this case, as we can see that the incident angle is having the value of 60 degree, and according to the law of reflection, the incident angle is equals to the reflected angle. So that's why the reflected angle will also be equals to 60 degree, right? Now the second type of question that can be asked to you, let me write down the second question. That is, suppose the diagram is given to you. Okay. In this case, the diagram is given to you like that. But they are not telling you that what will be the value of the incident angle or the reflected angle. They are just giving you the angles like that. Let me name it. This is A, this is O, this is B. And in that case, they are just having that value that is of 45 degree. They are just giving you one angle, right? Now in this case, let me name that this is a C and this is D. Now in that case, they are just giving you the value of this, that is of 45 degree, that is the angle of BOC. Now in that case, you have to find out the value of incident angle. You have to find out the value of reflected angle. So how can you find out? In this case, the angle which is given to us, that is of 45 degree, if the incident ray is coming on that surface with a particular angle, so obviously the reflected angle will be same as that of incident angle. So that means if this angle is 45 degree, so obviously that angle should also be of 45 degree, right? So according to the basic property of angles, what can I say? That we know that incident angle is equals to reflected angle. So all the total portion is of 180 degree, right? So I can write down 45 plus of, this is the incident angle I, plus of reflected angle R, plus of another 45, that is equals to 180 degree. We can write down that one. So in that case, what can I say? That this 45 and 45 will be equals to 90 plus of I plus of R equals to 180 degree, right? So now let's proceed with that portion. I'm just writing down at this point, that is of 90 plus of I plus of R equals to 180 degree. Then I plus of R equals to 180 minus of 90. So it is equals to 90 degree, right? In this case, what we know that the incident angle and the reflected angle both are same. So I can write down that it is of I plus of I, it is of 90 degree. In the place of reflected angle, we are using I. So it will be of twice of I equals to 90, and I is having a value of 45 degree. That means one thing is clear, if the incident angle is having the value of 45 degree, then obviously the reflected angle will also having the value of 45 degree, right? We'll move to the classification of the reflection, that means the regular reflection and the irregular reflection. But before that, let me solve one more question. Now, these are the very basic type of question. Now, if the question is like that an inclined plane is given to you, then in that question, how you find out the angle? Now, in this question, it is given that this is a one kind of incident ray that is falling on that inclined plane. Now, in that case, you have to find out the value of this theta. Now, after reflecting on that surface, it is just moved in this way, right? after reflecting of that surface, it is just moved in this way. So you have to find out the value of the incident, that is the value of the theta. The incident angle is given over here, that is of 10 degree. Now how to find out the value of theta over here? Now in this case, as you can see that the light waves after reflecting, it is just moved in this direction. So kitna minute? So after reflection, the light waves just moved in this direction. So obviously this angle should be of theta, right? Now in this case, if that angle is theta, so I can say that the rest of that should be of 90 minus of theta, right? What can I say? That the rest of the portion that should be of 90 minus of theta. Now in this question, it is given that there is an inclined plane, and in this case the incident angle is given as 10 degree, right? You have to find out the value of theta. Now if that angle is equals to theta, then obviously this small angle will also be equals to theta. Now if this small angle is equals to theta, then obviously I can say that this portion will be equals to how much? This portion will be equals to 90 minus of theta, because in this case this angle is also equals to theta, right? In this case, so what we should do in this case, you have to use the law of reflection. That means with respect to this normal, what can I say? That this 10 plus of theta is equals to 90 minus of theta, right? This 10 plus of theta, that is equals to 90 minus of theta. So what can we say? That this 90 minus of theta is equals to theta plus of 10. So that means we are just getting 90 minus of 10 is equals to twice of theta, and we are just getting 80 equals to twice of theta, and theta is having the value of 40 degree. So if the incident angle is getting the value of 40 degree, so we can say the value of the reflected angle will be equals to how much? So it is equals to 50 degree. So in that case, the incident angle is having the value of, with respect to this plane, what can we say? The incident angle is given as 10 degree with respect to the horizontal, but we have drawn normal with respect to that. So actually the incident angle with respect to this inclined plane, that should be of 40 plus of 10, that is also equals to 50 degree. So obviously the law of reflection is proved, that the incident angle is equals to the reflected angle. So this type of question can also be asked, and in that case you have to just solve in this way. What we have assumed, this small angle is theta. If that small angle is theta, then obviously this small angle with respect to the horizontal will also be equals to theta. So the rest of the portion will be equals to how much? That will be of 90 minus of theta, because the total angle is of 90 degree. Up to that portion, that means if the total portion that is of 90 degree, if one portion is theta, then the rest of the portion that is of 90 minus of theta. So in that case, what we have done, we have just added this to 10 plus of theta, that is the total incident angle is equals to total reflected angle, that is of 90 minus of theta. So 10 plus theta, that is of equals to 90 minus of theta, and after solving we are able to say that theta is equals to 40 degree. Now if theta is equals to 40 degree, then we have substituted the value, and the incident angle and the reflected angle both are having the same value. Now in the next case, we are just going to study that the type of reflection. What are the types of reflection? That is, one is the regular reflection, another obviously the irregular reflection, right? So we will understand these two phenomena as well. So what is regular reflection? So suppose if you are given a smooth surface, and if some parallel beam of light are coming towards the surface and they are just incidenting on that plane, so after the reflection they will also move parallel with each other. Now why that happens? Because a smooth surface is given to that. Now in that case, if some parallel beam of light rays are coming to that surface, now after the reflection they will just move parallel with each other. Now in that case, the incident angle is also equals to the reflected angle. If we just draw the normal with respect to that of surfaces, then you are able to see that the incident angle is equals to the reflected angle as well. Now this happens in the case of a plane mirror. Now in the case of a plane mirror, the surface is very much smooth, and when some light rays are coming towards the surface, they are able to reflect it in the same way. But what happens in the case of irregular reflection, that is, if a plane is given to that is not smooth, that is, suppose it's a curved plane is given to that, or a rough plane is given to that, and one of the other side of that is silver coated. Now in that case, what happens? Suppose the parallel beam of light rays are coming to this portion as well. If the parallel beam of light rays are incidenting on that surface, then after the reflection, as the surface is not smooth, it is very rough, so they just move in a different directions, right? In that case, they are just moving in different direction. They are just not moving with respect to parallel with each other. Now this type of reflection is known as an irregular reflection, because the parallel beam of light rays are incidenting on that surface, but after the reflection they are just going out parallel with each other. So in this case, the surface, as this is one of the very rough surface, so in that case we are getting that kind of reflection. Now there is a very good example of a irregular reflection, that is the cinema screen, or suppose the wall or any kind of portion which is very rough. The surface which is very rough, if the light rays are incidenting on that, then it will be deviated. It will be just deviated with respect to its original path, and it will be just flow out into the entire surface it will cover. That means in the case of a cinema screen, what happens? That means the light waves are coming from the backward of the cinema screen, and after the reflection it is being deviated all over the screen. Therefore, the viewer which is at any point of that cinema hall, he is able to view the screen. Same as the person who is just sitting in front of the cinema screen. So regular reflection and irregular reflection, they have some difference. That in the case of regular reflection, the light rays are coming towards the plane parallel with each other, and they are just moving from the plane parallel with each other. So in that case, it is very clear. That means if I am talking about the cinema screen, if it was a smooth surface, then only the viewers who are in front of the cinema screen, they are able to view that. If it was a smooth surface, as it is a rough surface, then the total light rays are scattered over the cinema hall, and everyone sitting at any of the corners of that, they are able to view the screen properly. Now we'll just move to the next portion of our topic, that we have covered that the type of reflections and so on. Then we'll move to the properties of plane mirror. So in the case of a plane mirror, what type of reflection we are able to see? Obviously, in the case of a plane mirror, we are able to see the regular reflection, because the light rays are coming in that way and they are just moving in the same way. It is not being deviated in any other directions, right? So this is the first property, that we can able to see the regular reflection in the case of a plane mirror. The second property, that in the case of a plane mirror, one funniest thing that we'll observe, that the lateral inversion. What is lateral inversion? That suppose I'm just writing down a letter, that is suppose P. So P can be reflected, so it's a source of light. It's not just a letter. From this letter, the light rays are coming out. So when we'll see the image of that letter, it will be like that. That means it will be laterally inverse. Then the right side of that letter appears at the left side, and left side of the letter appears at the right side in this case. Now why this happens? Because if you see some small example with respect to that. Now in that case, if you see a small example with respect to that, now in that case the light waves are coming to this portion and they are just getting reflected like that. Now the next property that we are going to analyze for the case of a plane mirror, that is the lateral inversion. Now in the case of lateral inversion, what happens if we just place an object in front of it, then right side of the object will appears at the left side and left side of the object will appears on the right side. Now in that case, at first we'll analyze that how the reflection happens over here. Now in this case, this is a source of light, right? So if it is a source of light, then obviously it is, if the light rays will come like that, and they will be, if the light rays are coming to this point, so they will be moving in the same way, right, as it is falling at a perpendicular, as the incident angle is perpendicular with respect to the plane. Now let me talk about one thing. If the incident angle is perpendicular with respect to the plane, then the reflected angle will also be equals to 90 degree. So in this case, the incident ray is coming to this plane, and this is a smooth plane actually. So the reflected angle will also be the same. So in this case, the incident angle and the reflected angle both are having the value of 90 degree. But if the light rays are coming like that, so in that case, what can I say? That it is falling with some angle. So in that case, what can we say? That if they are joined together, then the image will be formed like that. So in that case, we should use the arrow sign over here. Otherwise, the examiner will not be able to understand in which direction the light rays are going. So in that case, the one thing that is very much of clear, that both of the objects that should be of same size. As you can see in this diagram, both of the objects are in the same size. Don't go to my diagram. I've just drawn it to make you guys understand. Now some of the properties that we'll analyze from the concept of plane mirror. The first property, that the image should be formed, that will be a virtual image. I will tell you about the concept of real image and virtual image. Don't worry for that. The image that is formed, that is actually a virtual image. The second property, that the image should have the same size. That means the image size that should be equals to the object size, right? The third property that we can say, that the object distance, if the object distance that is equals to d, then obviously the image distance will also be equals to d. If you place the object close to that of mirror, then you will get the image that will be of same distance from the mirror. So the third property that I can plot, that is the image distance from the mirror. Image distance from the mirror, that is equals to the object distance from the mirror. Object distance and the image distance both are measured with respect to the mirror. Remember that thing. And the last and one of the most important thing, that is the lateral inversion property. Lateral inversion means, suppose in this case I've just used an arrow over here, but if we are using, suppose a letter, now if L is used like that, so in that case it will be laterally inverse and it will becomes like that. So as you can see that the right side of this alphabet appears at the left side and the left side of the alphabet appears at the right side, right? So in this case we can see that the plane mirror is having the property of lateral inversion. So the lateral inversion we have just explained, that in that case if you are placing any of the objects, it will be laterally inverse. Then the right side of that object will appear at the left side and the left side of the object will appear at the right side in this case. So how much properties we have gathered over here? So the image that we are getting with the help of a plane mirror, that is a virtual image. Why it is a virtual image? Now let me tell you about something about that virtual image. Now virtual image is a very different with respect to that of real image. Two kind of image that we can able to form in this chapter that we'll see, that is of real image and virtual image. So virtual image we are able to form when the light rays, they are not actually meet. In this case you are able to see that this portion of that plane mirror is coated here, right? So if the light rays are coming towards the surface, they are getting reflected back, as in this case the angle was 90 degree. But in this case the incident ray is coming towards the surface and it is reflected like that. But these two light rays, they are not meeting at any of the point. but they appears to meet at a point, right? If they appears to meet at a point, then in that case, whatever the image that will be formed, that will be a virtual image. And one of the most biggest property of virtual image is you cannot place that virtual image on a screen. That means the virtual image cannot be projected in any of the screen, right? But the real image that forms when the light rays meet with each other, then we'll get the real image. In the case of spherical mirrors, we'll clearly understand that what are the difference between this real image and the virtual image, right? Because in the case of real image, when the light rays after the reflection, when they will meet, we'll get the real image that can be projected on the screen also. But virtual image cannot be projected in the screen. Okay. Now, the next property, that the image size should be equals to the object size. They both are of same size and they both are of a same distance from the mirror. The last property, that the lateral inversion, that we have already told, that the left side of that object will appear at the right side of the image and the right side of the object will appear at the left side of the image. So this is the summary of the plane mirror. Now what are the different type of question that is asked from it? That is, the first question that is asked, suppose this is the plane mirror and there is an object which is placed in front of it, which is at a distance of 50 centimeter, okay, and the image is formed at a distance of 2x, right? The image is formed at a distance of 2x. So in this case, they will ask you that find the image distance. They will ask you to find the image distance from the mirror. What the thing that every student do the wrong thing in this case? What they will do, that they know that 2x is equals to 50 degree. So 2x is equals to 50. So x equals to 25. So the image distance that should be of 25. That this is wrong. They have just given you the thing that it is of 2x and it is of 50. So you just directly write down that the image distance should be equals to the object distance. So you don't have to find out anything. So the image distance that is of 50 only. Now the second question that they can ask, that is, I'm just writing down over here. In this case, if they are asking that there is an object which is placed over here and which is having a height of 2 meter, okay. So in this case, there is an image which you have got and they will ask you to find out the height. Now this is a very basic question. They will ask you to find out the height, but in this case they will make you confused that if the distance is d, that should be of 1.5, that will be of dx and so on. They will just make you confused after giving all of the values like that, but they will ask you the simplest thing, that if the object height is given that is of 2 meter, what will be the value of the image height? In this case, the image height will be of same, that will be of 2 meter. On the basis of lateral inversion, no question is asked, but from this concept of plane mirrors, this type of small questions are asked. Even some of the questions are being asked from the concept of reflection as well, and in that case they use a plane mirror. But we will always remember that the law of reflection will always be followed for any kind of reflection. Okay. Now we'll be moving to the concept of spherical mirrors. Now we are just moving to the next concept, that is a spherical mirror. What is spherical mirror? Spherical mirror, as the name suggests, it is a part of a sphere. Now this is a sphere, right? So the part of a sphere can be used as a mirror, that is known as a spherical mirror. So what are the different types of spherical mirror we will be understanding in this chapter? That is of two kinds of spherical mirror we'll be understanding. One is concave mirror, right? One is concave mirror, another is convex mirror. We'll understand this too. First of all, we'll understanding this concave mirror. what this concave mirror? Concave mirror, that means the mirror which forms like a cave. As you can see that half of the portion of this mirror I have erased, right? Half of the portion of this mirror I have erased. Now in this case, how can you recognize this is a concave mirror or convex mirror? Now, if the reflecting surface is like a cave, as you can see the inner portion of this, that means this portion will be the reflecting surface, and the outward portion of this spherical mirror is actually silver coated. If the outward portion of that spherical mirror is silver coated but the inner portion of that is a reflecting surface, then in that case we can recognize that obviously it's a concave mirror. So for the case of concave mirror or convex mirror, some of the properties that are very much same. In that case, that this mirror is a part of a sphere, so a sphere should have some center. So we have to draw that diagram again, because in this case we have just written that a reflecting surface and silver coated portion, because in this outward portion the light rays are not able to be transferred to another medium. They are able to come from one medium and they are able, after the reflection, they are just going back to the same medium. So that's why it is about a reflection. In the case of refraction, we are just going to understand the lens. What's the concept of lens? That is a concave lens and convex lens. But in that case, we are just going to understand the basic properties of a spherical mirror. Now, in the case of a spherical mirror, if this is a concave mirror, so in that case, this portion is one form of aperture. So in that case, it is written as AB. So it is known as a linear aperture. So there is a midpoint of the linear aperture. Suppose we are assuming that this is the midpoint. So this is known as a pole. Okay. So the spherical mirror, that is the concave mirror, is the portion of a sphere. So it should have some center, and we are using that as, suppose this is the center of that. And if we join the center and the pole, we will be getting one of the axis. And this axis is the principal axis in this case. This axis is known as a principal axis. So what do you mean by principal axis? If you are joining the center of that of spherical mirror, now the center is also having another name. This is known as a center of curvature, right? This is known as a center of curvature. So if you are joining this pole and center of curvature with a single line, you are getting principal of axis. So what is the midpoint of this center of curvature and pole? There should be a midpoint of that. The midpoint, that is the focus. So focus is the midpoint of center of curvature and pole, right? So in that case, if there is the center of that curvature and this is the pole, so obviously what can we say? That this should be the radius, right? A sphere has some radius, so obviously the spherical mirror should have some radius, and that radius is also known as r. What is r? R is actually the radius of this curvature, right? This is a curved portion now, so all of the names are like that. Center of curvature, radius of curvature. So in this case, as you can see that this is actually the distance from the focus and the pole. So that distance is known as focal length f. So what is f? F is the focal length, right? F is the focal length of that. So according to the diagram, we are just able to draw some relation between this focal length and the radius of curvature. What's the relation? That we are able to see that the focal length is the half of this radius of curvature, right? So we can conclude that focal length is equals to half of the radius of curvature, or we can say that the radius of curvature is equals to twice of the focal length. So one question is generated. What's the question? That they will give you the question for 1 marks like a story. That a lens is having that amount of length, focal length, curvature and everything and on, but at the end of that question they are just asking the relation between the focus and the radius of curvature. So if the radius of curvature, if the radius of curvature is 1.5 centimeter, find the focal length in meter. So they have asked a tricky question. It's not very much of tricky if you just read it carefully. In that question they have just asked if the radius of curvature is 1.5 centimeter and find the focal length in meter. So if the radius of curvature is given as 1.5, what will be the value of the focal length? The focal length will having the value of as r by 2, right? So what can I say? That this is of 1.5 divided by of 2. So that is equals to 0.75 centimeter. So this is the value of the focal length. But you have to convert that focal length from centimeter to meter. So what you have to do? You have to just divide that one with that of 100. So it is now converted to meter. So you can write it down as 0.75 into 10 to the power of minus 2 meter. So in this way it can be converted. This is one of the simplest question that is asked. Now a different question can also be asked from the same concept. Now if the focal length, now I am just writing down over here. Now if the focal length is 50 centimeter, if the focal length is 50 centimeter, find the radius of curvature. Find the radius of curvature. Now what the silly mistake that everyone does, that they just confuse between the relation of this r and f. Now if I will give you one MCQ type question where the options will be very much similar and you will take more than 20 to 30 seconds to answer that question, because in that case the relation between r and f, that is very much of simple. But when you are getting lot of options with that of same relation, that will make you confused. So in that case, if the focal length is having the value of 50 centimeter, you have to find out the radius of curvature. So what will be the value of the radius of curvature? We know the relation that the radius of curvature is twice of that focal length. R equals to 2f. We know that basic relation. So according to it, what will be the value of the r? That will be of twice of that focal length, that is of 100 centimeter. Right? In that way you can find out the solution of it. Now we'll go for that MCQ question that I am talking about. So in that case there is a question that which relation is correct about the radius of curvature and the focal length. Now there are four relations are given. The first relation, that is of f equals to twice of r. That means the focal length that is of twice of r, that means the twice of radius of curvature. Just remember one thing, that the focal length is always less than of a radius of curvature. So this option is eliminated. In this case the focal length, that is of 1/3 of r. So the relation of focal length and this radius of curvature does not involve the value of 1/3, 1/4, 1/5, nothing else. So this is eliminated. So in that case, in the third option, you can see that the focal length, that is of half of the radius of curvature. As we know in that of diagram, if we just draw it again, this is the pole, this is the focus, this is the center of curvature. If this is the radius of curvature and this is the focus, we can clearly say that the focus is equals to half of the radius of curvature. So third option is correct. So everyone, we are just finishing the class at this point of time. See you again in the next class. Till that time, just practice each and every concept. Now if you have any of the queries, just please email us in the given mail ID over here. Thank you so much.